Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session. So today is going to be for CBSE 10th, where we'll be talking about fours and more importantly we'll be talking about we'll be solving some problems regarding torque and principle of moment. We had studied about these two concepts in the sessions before. If you haven't watched the videos already, please do watch it so that you're able to make sense of what we're going to be doing in today's session. My name is Anam Baran, by the way, and welcome to today's session. Hoping that all of you guys are doing good. So people, this is going to be lecture number 3, which means that we've already done 2 sessions already, so make sure that you watch the recordings of all of that. Anyways, so as always, we'll be starting off this session also with a very interesting quote, and the quote for the day is this: work hard, dream big, and never give up. I don't think that's it's as explanatory as it gets. Yes, people, if you really want to achieve your goals, then yes, you have to put in the effort and make sure that you never give up on that and keep working your way through no matter how many times you fail at it. Alright guys, with that said guys, in the last sessions, like I told you, we had talked about torque and couple. We also did about equilibrium and principle of moments. Today we'll be talking about numericals based on those two concepts, that is torque as well as principle of moment. So with that said people, let me tell you one important thing before we get started, because in the last session, if you guys remember, I had given you a homework and I can see a lot of answers were given in the comment section below. Hats off for that guys. All of you guys did superbly well, but here are some of the names who who actually gave the right answer. But before that, let me tell you what the question is. So this is the question. So diagram below shows a uniform bar supported by a middle point O. A weight of 40 GF or gram force is placed at a distance of 40 centimeters to the left of point O. How can you balance the bar with a weight of 80 gram force? So you're supposed to find out what is the distance that you have to place that 80 gram force so as to counteract the weight that was placed on top of the scale. I don't have enough place to work out the entire problem, but I'm just going to give you a hint of how you're supposed to do it. So if you just remember the formula, I told you that if you talk about the principal moments, the principal moment says that the clockwise moment should be equal to the anti-clockwise moment. Only then you can achieve equilibrium. So to achieve equilibrium, so what I'm supposed to do is basically if you remember the formula, there is clockwise moment. I'm just gonna try and write it. It's gonna be super clumsy. Is equal to anti-clockwise moment. Anti-clockwise moment. So imagine there's a weight kept over here, which is 80 gram force. So I'm supposed to find out what is the distance. So if you have to calculate if you remember the formula of moment, it's nothing but the force into the distance from the center. So in this case, whatever is this distance, that's 40 centimeters. In this case, I'm supposed to find whatever is the distance, so that's x. So it's 40 into, sorry, so this is the clockwise moment would be basically produced by the 80 gram force. So basically I'll write that over here first. The clockwise, this will create the clockwise moment, this will create the anti-clockwise moment. So clockwise moment would be 80 into x is equal to 40 into 40. So we do the calculation, x is equal to 40 into 40 divided by 80. So 0 gets cancelled, 428, 248, so 2, yeah. So so you'll get the answer to be around 20 centimeters, and that, my friends, is the answer for that question. First of all, congratulations to all these names. By the way, we have Nityagya, I hope I'm pronouncing your name right, Shweta, Shivpriya, and Ayushi. Congratulations guys, well done, so well done. You guys were able to give me the right answer as soon as the video is out. Congratulations. And we also have some more names: Ankur, Amaya, Sahana, and also Vani Mithil. Congratulations, well done. Keep up the good work, and I hope to see more such answers from you people. Hats off for that. Anyways, with that said guys, now let us get started with the questions. So we're going to look at some very interesting questions, and I personally like these questions. So let's try to solve as many as we can, and more importantly, I want all of you guys to try out these questions. It's going to be super important. It'll definitely help you out. So what I want you guys to do is basically pause the video, write down the question, try to write down the answers. If you can, take a screenshot of this and try to do it by yourself, but that is definitely going to help you out rather than just watching me solve the question. So here's the first first question, guys. Consider a door having a width of 2 meters is being applied by a force of 20 Newton at the door handle. You're supposed to find out what is the torque obtained. Is it 10 Newton meter, 20 Newton meter, 30 Newton meter, or 40 Newton meter? Now remember the formula of torque is torque, which is represented as tau, is equal to force into the perpendicular distance. So just substitute the values, you'll directly get the answer. If you want to draw it out, so basically draw out a door. If you want, you can draw out a door. So now this is the handle. It's, let's say that this is 2 meter wide. So this distance is basically 2 meters. All right. This distance 2 meters, and you're applying a force of, let's say, 20 Newton. So you just suppose if I calculate the torque is equal to force into the perpendicular distance. Force in this case is 20 Newton into the perpendicular distance is 2. So the answer to this question is 40 Newton meter. So the torque is 40 Newton meter. So the right answer to this question would be option number D, which is nothing but 40 Newton meter. Hats off, guys. If you have given the right answer, then awesomely well done. Keep up the good work. And I want you guys to comment the answer down below. Let me see if you guys are able to give the right answer. All right. Second question. Here we go. The moment of force of 5 Newton about a point P is 2 Newton meter. Calculate the distance of point of application of force from the point P. Is it 0.1 meter, 2 meter, 0.4 meter, or 0.2 Newton meter? So you're supposed to find out what is the distance in this case. They're giving you the torque. They've given you the force applied as well. You're supposed to find out what is the distance. Again, write down the formula. I would suggest you guys to write down the formula for each and every question given, because you get step marks, especially in ICC. There's a lot of step marks given. So please make sure to write down the steps. It's going to be super important if you don't want to lose marks, because there'll be a lot of 5-mark questions and stuff like that, right? So try to write down the formula as well, right? So here we go. Torque is equal to force into the perpendicular distance. So they've given you the torque, so that's 5 Newton. Force is given as, torque is given as 2 Newton meter. Sorry about that. Torque is given as 2 Newton meter, and the force is given as 5 Newton. You're supposed to find out what is the distance. So distance is equal to 2 divided by 5. So 2 2s are 4. So that's 2.1 divided by 2.5. So 1 by 2.5, or in other words, the answer can be 0.4 meter. Yes, the answer will be 0.4 meters if I'm not wrong. Yes, so the answer will be 0.4 meters. Very simple question, guys. Again, you just have to rearrange the equation to get the right answer. That's all. It's very, very straightforward. Just put on the values and you'll get the answer. Done. That's it. All right, guys. So the right answer to this question is option number C. So by that we have completed 2 questions, but then these are like these might be asked as 2-mark questions at the most. So yes, don't worry too much about it, because right now we're going to get into the questions which will be asked, which were asked in some of the board exams. So this is one such question which was asked in 2014 board exam. Here was the question. 2 forces each of magnitude 5 Newton act vertically upward and downward, respectively on 2 ends of the uniform rod of length 2 meter, which is pivoted at its center. Determine the resultant moment of force about the midpoint of the rod. Is it 10 Newton meter, 5 Newton meter, 15 Newton meter, or 30 Newton meter? Now, for all those who are not able to understand this question, let me just draw it out for you guys. Imagine there's a rod. All right, imagine there's a rod of length 2 meter. All right, so this length is 2 meter. All right, this is 2 meter length. Okay. Now, there's one force acting upwards, 5 Newton, and there's one force acting downwards, 5 Newton, and it's pivoted at a point which is at the center. So basically this is the point, and let's say that this distance now is 1 meter, because obviously it's divided exactly at half. No, so this distance is also 1 meter. Now what I'm going to do is that I'm going to name these points as A, B, and let's take this as O. All right, just for our satisfaction, I'll take it as A, O, and B. Now here's the question. You're supposed to find out what is the resultant force of both these forces on the midpoint. All right, so for the first one, what I'm going to do is that I'm going to calculate what is the force of, what is the moment about O by A. So what is the moment that is caused at the midpoint because of the force at A, that is 5 Newton. So to calculate the formula, the formula is basically very simple. It's nothing but force into the distance from the midpoint. So in this case, it's nothing but the force into the distance from the midpoint. So the formula is this. So if you have to put on the values, it's nothing but 5 into 1, which would give me 5 Newton meter. So that is the moment about O. Now to calculate the moment about O because of B, the force on B. Exactly the same thing, do the exact same thing, moment about O by B. So in this case, again, put on the formula, force into the distance from the midpoint. So it's 5 into 1 again. So that gives me 5 Newton meter. So what is the resultant moment? So the resultant moment is equal to 5 Newton meter plus 5 Newton meter. That gives me 10 Newton meter. As simple as I guess. So it's a direct substitution. I mean, you just have to put down the values and get the answer. Very simple. Sum it up, you'll get the answer as 10 Newton meter. As simple as that. Direct question is, and this was in the board exam, 2014 board exam. All right. Now here's another very interesting question. Guys. This is the fourth question, but it's a very very interesting one. Here's a question: a roller of diameter 0.4 meters. So this distance, or the diameter is 0.4 meter. All right. Is raised on a pavement XY by force F1 and F2. This is force F1, this is force F2. Each of magnitude 10 Newton. So this is 10 Newton, this is also 10 Newton. You're supposed to find out what is the ratio of torque produced by the two forces. Alright, so you're supposed to find out what is the ratio of torque produced by the two forces. Your options are these: 2:1, 1:2, 1:1, and 1:4. It's actually a very interesting question, guys. It's pretty simple also. So for the first one, let me just try to draw it out for you guys. So this is what the diagram looks like. So there's one force F1 over here, and there's one more force over here, that is F2, and both the magnitude of the force is same. It's 10 Newton itself, and it's basically you're trying to push it over the pavement. All right, so that is your task. Now here's the thing: what is the formula for torque? Torque is nothing but what? Torque is equal to force into the perpendicular distance. Now for F1, what is the perpendicular distance? It's nothing but this distance. It is nothing but from this point to this point, because it's basically going to rotate over that, right? So that will be the point where it's going to rotate on. So you can say that the distance, the diameter of the circle is basically the distance or the perpendicular distance for force F1. For force F2, the perpendicular distance is basically this distance. Now the diameter of this particular circle or this ball is basically, or this roller is basically 0.4 meter. If the diameter is 0.4 meter, what would be the radius? 0.4 divided by 2, that's 0.2 meter. Why am I finding out the radius? Because it's this perpendicular distance, this distance. So let me just draw that with a different color. So this distance is what I want to find out, because the again, force into perpendicular distance, so that distance over there is 0.2 meters. It's nothing but the radius itself. Now put on the values, people. It's as simple as that. So for F1, I'm going to write for F1 is equal to this is 1 force into the perpendicular distance. Sorry, for F1, sorry, let me find out the moment. So sorry, the torque. So if you want to find out the torque is equal to force F1 into D1. I'll just take it as D1. So for the first one, F1 is 10 into D1 is 0.4 meters. So that gives me 40. Yeah, 10. Okay, no, it will be 4. Sorry. 4 Newton meter. Yeah, I got as 4 Newton meter. Now for the second one, tau 1, I'll take it as tau 2. This is F2 into D2, which again is 10 into 0.2, which gives me 2 Newton meter. Now, the question does not end here. They're asking you what is the ratio of the torques. So what is the ratio of torque? It will be tau 1 divided by tau 2, tau 1 divided by tau 2. So what is tau 1? 4, tau 2 is 2, 2 2s are 4, so it will be 2:1. So the answer to this question will be 2:1. Very simple, guys. Again, it's a very interesting question. It's actually one of my most favorite questions that we have seen so far. I mean, in this particular chapter. So it's 2.1, 2:1 would be the answer to this question, where again, the ratio of torque produced is 2:1. As simple as that. Alright, guys, moving on to the next question now. This is a much more recent question that was asked in 2019 board exam. So the question is this: a uniform meter scale is in equilibrium as shown in the diagram. calculate the weight of the meter scale. You're supposed to calculate the weight of the meter scale. We have done so many questions based on this in the last session also. So the fulcrum, or it is balanced, in other words, at 30 centimeters. You're supposed to find out what is the weight of the scale. Now here's the thing, guys. Remember I told you about center of mass. What is the center of mass? The point where the mass is concentrated. Now, for a body, generally the center of mass is pretty much in the center. So if you talk about a scale, the center of mass will be at 50 centimeters. Because it's a 100 centimeters long scale. So the center of mass will be 50 centimeters. I'll just take that as 50 centimeters. It is not exactly in the center, but I'll just take that as 50 centimeters for now. All right. So I am supposed to find out what is the weight of the scale. All right, so the center of mass is over there, so all that weight is concentrated over there. So the that is basically the distance from the center. So what I'm going to do, I'm going to find out the distance from the fulcrum to this point where the weight of 40 GF is acting, and I'm going to find out what is the distance between the center of the mass and center of the mass of the scale and the fulcrum. So in this case, it is at 5. It is kept at 5 centimeter. So this distance would be 25 centimeters. 30 minus 20 minus 5 is 25 centimeters. In this case, it's at 50 centimeter. So the distance is 20 centimeters. So I found out the distance. Now that you know all these values, try to find it out, guys. So these are the options: 50 GF, 20 GF, 10 GF, and 15 GF. So I'll just do it over here itself to avoid confusion. So these are the values that I've given. So what is the for a body at equilibrium according to principle of moments? I told you that clockwise moment should be equal to anti-clockwise moment. So clockwise moment in this case, clockwise moment should be equal to anti-clockwise moment. Anti-clockwise. Right. All right. Now again, guys, I want all of you to try out the question on your own now. Don't just wait for me to solve it. So anyways, clockwise moment is basically what is the formula? It is force into the perpendicular distance, or distance from the center in this center, or basically the fulcrum. So in this case, it will be 40 into 25. And in this case, I don't know the weight of the scale. So I'll just take this as X. So X into 20, the weight into the distance, that is the distance on the midpoint again. So again, rearrange the equation to get X. Simple arithmetics, divided by 20, 2. So 2 into 25 is again 50 gram force would be the answer. Very simple, guys. So the answer to this question would be basically 50 gram force. As simple as that. So the answer is option number A with 50 gram force. That is the answer to this question. It's a very simple question, guys. Again, we've already done this a couple of questions in the last session as well. So I think you guys were able to give me the right answer. Nonetheless, well done, people. If you weren't able to give the answer, again, that is how you do it. Remember the method. Always make sure that you take the center of gravity, find the center of gravity. I mean, in a scale like this, the center of gravity will be generally at the midpoint itself. That is at 50 centimeters. So you have to use that distance. Don't just take any distance. All right. Here's another interesting question, guys. Now, here, this question is actually pretty, it takes a little bit of imagination of yours. So the question is this: a half-meter rod is pivoted at the center with two weights of 20 GF and 12 GF, suspended or at a perpendicular distance of 6 centimeters and 10 centimeters from the pivot respectively, as shown in the given figure. Find the direction of 20 kgf force is, if it is reversed, what is the magnitude of the resultant moment of the forces on the rod? So they're asking you what would happen if you take this weight which is applied over here and place it over here. All right, you're going to place that over here. So you're supposed to find out, so that distance will also be 6 meters itself. So the diagram would basically look like this. So what are you going to do? You're going to place that. The question is, what if you remove this and place it over here? You're supposed to find out what is the resultant moment. That is what you're supposed to find out. All right. So this distance will also be 6 meters itself. 6 centimeters itself. So you're supposed to find out what is the resultant moment. It's actually, now that you've understood this question, it'll be much more easier. So you're removing this completely and you're placing it over here. So there's nothing over here, which means that both of them are going to create a clockwise moment, and that means that both of them should be added up. So if you find out the moment and add it up, you'll find the answer. As simple as that, guys. So these are the options. This was again a 2018 board exam question with 200 nanometer, 150 200 Newton meter, 120 Newton meter, 240 Newton meter, or 220 Newton meter. So anyways, guys, the question is this. So let me just try to solve it for you people. So moment about point O, or the clock, we can write as clockwise moment also. I'll just write it as a moment about, what did we take this as? Okay, we'll just name it as okay, moment about midpoint. I can take it as moment, or we'll just take it as clockwise moment just to avoid confusion. So we'll take it as clockwise moment, because again it's creating both of these two, because it's on one side, both of them are creating clockwise moment. So clockwise moment is equal to basically the force F1 into D1 plus F2 into D2, because they're on the same side, they're creating a clockwise moment. So F1 is what? F1 is 20. I'll just take it as 20 into 6 plus F2 is 12 into 10. So what is the answer? That'll give me 120 120 plus 120, which gives me 240 Newton meters. So the answer to this question would be 240 Newton meters. So the option number C would be the right answer for this question. It's just, again, you just have to understand the question a little. That's all. If you can imagine this, that you're removing the force and keeping it on the other side, this question is actually the same thing that you did before. It's damn easy. If you just do this, if you can just do that, it's actually pretty easy. So just remember this, guys, that if you're asked question like this, look for the keywords, like if it is reversed or stuff like that, look for these kind of keywords, and if it is given, then go with this methodology. It'll definitely yield you the right answer. All right, so that is the answer for this question, guys. Moving on to the 7th question, which was asked in 2017 board exam. This was the question: a uniform half-meter rule balances horizontally on a knife edge at 29 centimeter mark when a weight of 20 gram force is suspended from one end. Draw the diagram of the arrangement, and what is the weight of the half-meter rule? So that is the question. So a half-meter rule scale, that means basically it's a 50 centimeter long scale. So I'm just going to take it as centimeters. So it's a 50 centimeter long scale. First of all, it's a 50 centimeter long scale, because again, 1 meter, 100 centimeters. Now, the edge, the knife is basically kept at 29 centimeter. So it's balanced on a knife at 29 centimeter. So this distance, I'll take it as 29 centimeter. 29 centimeter. All right. Now, they have asked us, there's a weight that is kept, that is suspended at there's a weight of 20 gram force suspended from one end. So I'll just take that over here. Okay. So 1 second. Yeah, the weight of 20 grams is suspended from one end. Draw the diagram. Okay, yeah. So okay, let's first check the center of mass. So center of mass, if it's 50 centimeters, then the center of mass will be at 25 centimeter, somewhere in the middle. So I think I have just that's why it was a little confusing. Hold on, guys. Let me just move the position of the knife. So 29 centimeters, it's a 50 centimeters long scale, so 29 will be somewhere over here. I'll just take it as over here, and I'll say that the center of mass of this is at 25 centimeter, which I'll take it exactly at half. So this is 25 centimeter that is at the midpoint. That is where the center of mass is. Now it makes more sense. So now what you have to do is basically draw out there's a weight of 20 gram force that is applied over here. So this is 20 gram force that is kept at one of the ends. You're supposed to find out what is this weight. What is the weight of the scale? So again, guys, find out the distance from the center for all of these. So for the first one, if you just talk about this one, the distance from the center to the center of mass of the scale, that is 29. 1 second, let me erase this as well. Yeah, so that is 29, this distance, 29 minus 25, so that gives you 4 centimeters. So this distance from here to here is 4 centimeters. All right, and the distance from here to here is how much? So if this distance is 29, it'll be 50 minus 29, which would give me 21 centimeter. How did I come to that? The length of the scale is 50 centimeters. The midpoint, or where it is balanced, is 29 centimeters, and they've told that the weight is at the end of it. So I'm just going to subtract the total length minus 29. I'll get us 21 centimeter. So this distance is 21 centimeters, and the distance from the center of mass and the point where it is, the fulcrum, in other words, is nothing but 4 centimeters. Now that you have all these values, try to find out the moment. So try to find out, use the formula of principle of moments. So principle of moments basically states that for a body at equilibrium is basically clockwise is equal to anti-clockwise moment. So clockwise moment again is equal to anti-clockwise moment. By now this, though, you can remember it even in your sleeps. Yeah, I've written it so many times on the screens right now. All right, so clockwise moment is equal to anti-clockwise moment. So find out what is the value for clockwise moment. It is nothing but this one. So this is the one that produces the clockwise moment. So 20 into the distance is 21 from the center. For the second one, it's basically x, because I don't know the value, into the distance is 4. So x is equal to 20 into 21 divided by 4. So 4, 5, 20, 5, 2, 5 to 10. So it will be 105 Newton meter. That is not Newton meter. Yes, it will be, no, not Newton meter, it will be gram force. Sorry guys, it will not be Newton meter, it will be gram force. Yes. So that is the answer, guys. That is the answer for this question. It will be 105 gram force, which is option number D. 105 gram force. That's it, guys. Very simple question. This was 2018 question, if I'm not wrong. This was 2017 board exam. Next question, guys. Moving on to the 8th question for the day. Here we go. 8 questions so far. All right. A body of mass 30 kg is sitting at a distance of 2 meters from the middle of a seesaw. Where should a boy of mass 40 kg sit so as to balance the seesaw? And this was 2012 board exam question. Your options are 1.5 meters, 2 meters, 3 meters, or 0.5 meters. So, okay, let me just draw the diagram first of all. So there's a seesaw of 2 meters in terms of length is 2 meters. All right, 2 meters in length, and there's a boy sitting, a boy of 30 kg sitting over here somewhere. All right. Okay, sorry. No, not wrong diagram. Sorry, guys. All right. So I'll just draw the diagram again. So here we go. So seesaw, 30 kg, but he's sitting from the like he's sitting 2 meters from the midpoint, from the middle. So 2 meters from the middle. I'll just take this as 2 meters over here. So the boy is 30 kg. I'm supposed to find out. So this distance is 2 meters. Yes. Alright, I'm supposed to find out where is this boy supposed to sit so as to counteract the clockwise moment created by this boy. So again, guys, same old. So you're supposed to find out what is this distance. So first of all, again, clockwise moment is equal to anti-clockwise moment. So clockwise, I'm just going to write it as clockwise is equal to anti-clockwise, because you know what the rest of that is, anti-clockwise. So put down the values. So it'll be 40 clockwise moment is created by this person, right? So it'll be 40 into x, anti-clockwise is 30 into 2. So it'll be x is equal to 30 into 2 divided by 40. So 0 gets cancelled. So it'll be 3 by 2, which gives me 1.5 meters would be the answer. As simple as it is. So the right answer to this question would be 1.5 meters. Again, it's a 2012 board exam question. You never know, because ICSE has this pattern of choosing up questions from the past 10 years. So you never know, these are the questions. The values might differ, but the methodology remains the same. So try out these questions. It'll definitely help you out. All right. So the right answer to this question is 1.5 meters. Moving on to the 9th question. Actually, this was the year that I wrote my board exam as well. 2011 is where I wrote my board exam. So yeah, this is the Question: a mechanic can open a nut by applying a force of 150 Newton while using a lever hand of length 40 centimeter. How long a length is required if he wants to open it by applying a force of only 60 Newton? Is it 6 meters, 3 meters, 1.2 meters, or 1 meter? So you're supposed to find out the distance. So he's able to apply the force to open the nut. He has applied the force of 150 Newton at the length of 40 centimeters to open it. Now the question is, if he just wants to apply 60 Newton force, where should he apply the force? That is the question. So this question, basically what you have to do is, guys, equate the torques. Equate the torques of both of them. So basically when you equate, I'm just going to write the statement, equate both the torques. Both the torques. Alright. So for the first one, what is the torque? Torque that I'll just take it as T1 is equal to T. So I'm supposed to equate these two torques. The torque produced by the person when he applies 150 Newton force at 40 centimeter length, and I'm supposed to find out what is the torque. What is the torque applied when he applies a force of 60 Newton? I'm just supposed to find out the distance. So in this case, torque basically is equal to what? Force into the perpendicular distance. So I'll take it as F1 into D1 is equal to F2 into D2. So F1 is 150 into the distance is 40. F2 is 60 into distance is X. So find it out. 150 into 40 divided by 60. As simple as that is. 2 2s are 4, 2 3s are 6, 2 5 15. So 0. That would give me 100 centimeters. So if you want to convert that to meters, that is also fine. So 100 centimeters is nothing but 1 meter. So the answer to this question, guys, is 1 meter. As simple as that. That's all, guys. Now that you've solved all these questions, obviously I'm going to give you a homework question as well. So try to answer the question as soon as you can and put it down in the comment section below. So here is the homework for the day, guys. An iron rod of a building is 3 meter broad. It can be opened by applying a force of 100 Newton, normally at the middle of the rod. Calculate the torque needed to open the door. That's all. Okay, it's a straightforward question. Just try to do it, guys, and let me know what is the answer in the comment section below. And with that said, guys, that is it. It's me. It's time to bid adieu. Thank you for joining today's session, guys. I hope you guys enjoyed it. I hope you guys found it really helpful. If you guys did enjoy today's session, leave a like and also share it with your friends and your colleagues. And also subscribe so that you are able to notify yourself as soon as the video is out. If in case you want to reach out to me personally, you can reach out to me on anup.manoharan@vedantu.com. That's my personal email ID. You can reach out to me on that. Thank you for joining. Until the next time, this is Anup signing off for the day. Take care, guys. Bye bye. See you.